move forward with the next speaker.
The next speaker is Boguslav Michalik, Associate Professor of the Glovny Institute Gornichkva, also called the Central Mining Institute. And the time is 20 minutes for the presentation.
Only 20?
Only 20, unfortunately.
I was prepared for the 25. Because
Was my mistake. I say 25, but I check on the program is 20 for the
okay, so I try. Oh, okay.
20 minutes, and then we will have 5 minutes for questions. Thank you.
Okay, thank you very much.
And the floor is yours.
So thank you for the introduction. So I would like to talk about the problem of the management of the norm waste and remediation of the norm affected legacy site. So just to show you the existing situation and just point out a kind of the improvement option. So what is the source of data considered in our work? So the first, of course, it is the individual input for all participants involved in the task. So the second important source is the norm survey, about which Jelena was already speaking, and some radionorm deliverables and articles already published. And of course, we base on the literature review, and mainly what was considered is the material from the norm conferences, as well as the proceedings from the European Norm Association workshop, and the previously it was the ALARA network for norm meetings. So also we considered some recommendation and some information provided by the International Association of Norm Involving Industries, as for example, European Coal Combustion Product Association, International Association of the Oil and Gas Producers, Zircon Industry Association, and the European Sustainable Phosphorus Platform. So as you can see, as you already know, so it is the typical norm involving industries which are included in the list published by IEA, as well as included in the European directive. So first, what we have to consider when we're talking about the treatment option and the management of the norm, so we have to focus on the specific features of these materials, and what is the important from the perspective of the management and the treatment. So of course it is the information that usually when you're talking about the norm waste or the norm residue, we are talking about the bulk materials which are occurring in the very big amount. So, and other hand, our approach usually is driven by our experience collected in frame of our activities related to the artificial radionuclides. So, and then in this case, we have to point out that when you're talking about the norm, they tend to have more in common with the industrial waste than in the radioactive ones. So that it is the important issue, and plenty with the different consequences. And last but not least, also what is the different from this situation when we're talking about the artificial radioactivity is that when we're talking about the naturally occurring radionuclides, always we have the problem also with the other non-radioactive pollutants, which just create the multiply stressor scenario, and very often are much more important than the natural radioactivity. So these features of the norm just created a very special situation, and that just very often determine what we can do with this material. When you're talking in general about the management of the normal waste, so we have to just consider it in the frame of the conventional management of the conventional waste, because, as I said, they have the much more common with such waste. Please don't work. Okay. So, and first we have to consider this situation as we have in the industrial waste. So if we just thinking about the management, and then we try to mitigate any kind of of effect caused by the waste. So first we have to consider the possibility that we can just minimize the total amount of the waste. So, and then of course this problem could be solved only on the level of the technological process, and then we need then some modification of the technological process. Finally, just expecting that the overall amount of the waste will be lower. So this activity is just common and recently, because we are just talking about the zero waste economy. So, and then it is exactly the same approach as in case of the other type of waste. So what we also could do, just talking about the technological process, we can consider the raw materials which are used in our processes. So, and then sometimes we have some possibility to change the raw materials just to get as an input material with the lower radionuclide activity concentration. But such option is very often very limited, because just in some norm involving industries, usually we are using the same materials. However, in some cases, such option is possible. So, and then it is more or less all when we're talking about the general management of the norm waste. So, and then we can look in the treatment option. So, and again, we can just we have to apply the same approach as we have in case of the conventional waste. So then we have to consider the option for the disposal and recovery. In the disposal, and we have some set of the already existing options. So, but when you're talking about the recovery, so it is then necessary just to limit ourselves to only very few situations. So, and then we can consider the reprocessing in frame of the one production process. We consider the purification, and what is the most common when you're talking about the norm is the mixing or dilution under condition given in the European directive, European Basic Safety Standard. Reuse and recycling, so also the existing option, but we have to be considerate about the actual meaning of this word, because the reuse and the recycling, the terms were just prepared for the management of the classical waste. So, and sometimes it is the problem with the proper interpretation of these terms in case when we're talking about the norm. So it is the only one way to improve the existing situation. So, and then just going into details. So what is the most common when we talking about the disposal option is, of course, is the deposit into or onto land. So about the landfill, what Gennaro was talking about during the previous presentation. The second and the second most common option is the blending or mixing, and then it is especially important or applicable due to the recent requirements set by the European Basic Safety Standard, when we have the one article which allowed the industry operator just to use this process. However, a lot of the different processes which are used toward the norm should be considered exactly in this terms. So what I will be talking about a little bit later. So, and then of course we have some different some different other options. So, for example, the surface impoundment, so permanent storage. But it is we have some examples, but it is not so common when we're talking about the norm. So, what we can say about the landfill. So usually the situation is that for norm are just used the already existing landfills which were prepared for the dangerous waste. So, and then usually no special construction, no special modification of existing facility are applied. And site evaluation is done using the adapted for this purpose radioecological models. So, and then you have the example from the previous presentation. And usually the criteria which are used are this activity concentration, and it is usually just the clearance level and 10 kilobecquerels per kilogram, which sometimes is used for the classification waste as a radioactive waste. So also you have to consider the special approach and the more detail, and we can try using the model, we can try to calculate the special operation level as it was showed in the previous presentation. But honestly speaking, beside the disposal on the landfill, we have some examples. The special approach was already developed, and one of the well-known situation is in Norway. So Jelena already was talking about this. So I think that is the only one example where, especially for the norm, the special underground repository was prepared. This is the underground repository. So, and then idea is just to collect and to dispose the all waste from the Norwegian oil and gas industry. But the declaration is that the capacity is big enough to receive the all European oil and gas industry generated norm. So, but of course, this option is very, very costful. So, and then it depends on the economy, and but we know that the oil and gas industry is a rather rich industry, so maybe it is a good option for this situation. The other also specific option which is already applied, we have an example from the Netherlands. So in the Netherlands we have a quite well developed system for the management of the norm waste, and then in this case we have such option that after the special method of the classification, some norm waste which are with the activity concentration above the specific level set in this regulation are just disposed into a radioactive waste repository, which is the name in Kovra in Netherlands. So, and then you can see some picture. So it is the norm waste are just in the barrels built with the concrete, so it is completely immobilized. But what is the important in this case? The majority of those waste are from the gas industry and contain lead-210. And the idea is just to wait, let's say some 100 of years, till the lead-210 decay completely. So it is the justification for this approach. So it is not forever, but only for some relevantly short period of time. So, and then it is the more or less about the disposal. When we're talking about the recovery, so the most common situation where the norm are used is, of course, the application in the construction industry. The second, it is not so often, but if a country we have the mining, especially the underground mining, also the open pit mining, so this waste material could be used for the backfilling, or the fire explosion protection, or the other engineering in such a cases. But honestly speaking, what I can say in this situation, mainly the coal combustion product are used. But of course, there is nothing against to use the other norm materials for this purpose. And the third option of the recovery is the land treatment. But as I said before, the all above might be, or not may, but should be considered in terms of the dilution, blending, or mixing, because in each case, finally, this is the main process leading to the neutralization of the natural radioactivity. So, and then it is the one example from the land treatment. So, and then it was the similar evaluation was prepared as this presentation given by Gennaro previously. So it is maybe exactly the same team is responsible for that, and a very similar approach when the norm waste are used for the land treatment as a fertilizer. So, and then what is the effect of this simulation is that really we can apply this process, but we are very limited, because just finally we get the activity concentration, the operational levels for the radium-226 and the radium-228 decay series at the order of the 1 kilobecquerel per kilogram. So it means that at the level of the clearance level. So, and then it means that this option is can be applied, but we are limited, and then it is the problem how we can treat before our norm, before we try to use them for these purposes. But such option exists and also is important. In general, when we're talking about the solid norms, the situation is much more clear because some options exist, and then a lot of things is already done in this matter. The more complex situation is in case of the liquid norm. So, and then in the liquid norm, we have no such strict requirements as in case of the solid. So we have no clearance level. We have the only general recommendation that we have to avoid the additional exposure to the environment. We have to avoid the contamination of the drinking water. And of course, we cannot exceed the dose for the human. So, and then it is in some countries, we have some approaches which are applied. But usually, if we use the dose as a criterion for each treatment option, so it is the problem how we should calculate the dose, especially when we consider the environment and any kind of the ecosystem exposed, which is of course necessary in case of the water. So, and then still we have the problem, and then we have no any kind of even a recommendation just concerning the treatment of liquid norm. But this problem, it is very important. Just consider the amount of the liquid norm which we have even only in Europe. So, and what is the reported activity or the treatment of the liquid norm? So, the most often option is just discharge to the seawater or into inland water without any kind of the monitoring, assuming sufficient dilution level. So, and then if we have a justification for that, it could be just good approach, but usually it's not working properly, and then we have the very doubts about this solution. So what we have sometimes, what is the quite common situation is that this process of the discharge to sea or to the inland water is going on under controlled condition, but the conditions are set from the perspective of the other type of the hazard other than radioactivity. So it is usually the chemical contamination, and then when we're talking about the discharge of the liquid norm into inland water, usually the main problem is related to the high mineralization of this water. So it means the very high content of the salt. So what is also the option, and then sometimes very efficient, is reinjection. But in this case, we have some other problems, even what is not so easy to make a kind of the collocation, but this process of the reinjection could be responsible for the increase of the earthquakes in this area. So, but it is there for the longer discussion. So, and then just looking on the liquid norm under the specific industries. Of course, you know very well that the oil and gas exploitation is the main source of the liquid norm. So, and then first, when we're talking about the offshore oil and gas exploitation, so it is the common process is just to discharge this water into sea, and the justification that the water will be diluted in the good enough level, so usually it's working properly. But in this case, again, what I said at the very beginning, usually the radionuclides are not so important issue. And then we have to consider the presence of the other contaminants, and then in this case we have some hydrocarbons. So, and then sometimes we observe such situation that this water is purified from the hydrocarbons into before the discharge into sea. But this is not working and they're not doing anything against the radioactivity. So, and when we're talking about the other contaminants included in this water, so mainly the high mineralization and the high salinity. In case of the offshore, it's not so important because in general the properties of such water are quite similar to the water in the sea. So And what is the observed? And we have some information that it is the interest in the recovery of the valuable elements from the produced water in the different situation. And the most common element which is expected is the lithium. This is by far from the radioactivity, but also should be considered in these terms. So, and then just what is the problem in this such a disposal of the liquid norm? So it is that we observe some significant increase of the activity concentration if the seawater. Of course, we are still at the very low level, but it is the observable. So we have some data and some models developed for that, and then it is quite easy to predict or even to measure that we have some increase of the background content of the natural radionuclides.
2 minutes left, Boguslav. Sorry.
Sorry?
2 minutes.
2 minutes. So it is the half of my presentation. Okay. So skip this discussion about the liquid, because it is the very long and difficult problem. So I would like to share this information about this. But of course, I'm ready to provide you with the information about this. So the last but not least problem is the legacy site. So usually in the legacy site we have the problem with the radioactivity, and what is the reported, what is the most important issue which should be considered at this level is just to know where we have the legacy site, and then characterize them in the terms of the natural radioactivity. And also, what is the important issue, what we discuss in our team, is just to recognize and define the legacy site in the proper way, just to distinguish between what is going on site and what is going off site. So just it is a very important assumption for the further treatment, first for the characterization and for the further treatment of this waste. So just skip the summary because it is obvious, and then quickly towards about the improvements. So the method which is used sometimes especially for the water, it is the purification. So then we can consider this process, set the situation upside down, and consider not as a purification but as sourcing of the valuable element which is dissolved in the water. So then we have some examples and ongoing in the Radon project. Just focus on the sourcing of the barite from the mine sediments, and then we have the very good example from the one mine nickel ore mine in the Finland, where the water with the high content of the uranium, first considered as a pollutant, now is used for the sourcing of the uranium, and it seems very efficient. And just going to the summary, what is the important and what I said at the very beginning, the norm are very similar to the ordinary industrial waste. For this waste, we have the already very well developed system of the management. So, and then just making the very short analysis of the existing regulation, European regulation about the waste and the waste from the mining industries. So it is clear that the norm management and the treatment system might be established based on this existing regulation, unless the norm are reclassified as a radioactive waste. So, and then it is the problem how we should consider this radioactivity in our norm waste. So then already we have some agents which are considered and making the waste as dangerous. So, and then you can see this is some elements which are also very similar to the radioactivity. And then when you compare the chemical toxicity and the radiotoxicity, so all requirements sent for the landfill are just prepared considering the chemical toxicity of the material which is disposed. So, and then Of course, such a landfill should protect against the dispersion, direct contact, migration to the environment, food chain contamination, and et cetera, et cetera. So, and then, but this regulation about the cancerogenic agents are, so I finish.
Okay.
So
Thank
I
you,
finish.
Boguslav, because
Sorry, lunch is just already prepared, so then don't worry, no one is. Okay, so and then of course this regulation about chemical toxicity that include the properties of the radiation. So and then just considering the already existing landfill which was prepared for the ordinary waste, and then we want to put into this landfill the norm. So what we have to consider only the again some features which just minimize the external radiation caused by norm. So and then of course this is the problem was already just raised by Jelena. So it is the problem when the norm is classified as a radioactive waste or not. And then it seems that it is must be one of the most important questions to be solved. And of course the circular economy, as I said, any kind of the purification can be considered as a sourcing of the material. So it is a very good example from the sourcing of the radium from the mine sediments. So just you can check this. It is, I think that it is a quite interesting situation. So and then at the end, so just when we're talking about any kind of the improvement, so it should be considered as an improvement in the regulation, because the existing practice is quite good, and then we have to adapt the regulation to the existing practice. So thank you very much, and very sorry to talking too much.
thank you very much, Boguslav.
So I look at the organizer. Do we have time for questions? No.
No time for questions, but
Boguslav is,
will be at
of
lunch
course, at lunch, and
with
so
us.
you can ask them.
Exactly. Feel free to sit at a table with Boguslav during lunch and continue the discussion. I would say we break for lunch now and we meet at 1:35. So 1:35.
So thank all the speakers again, and have a good lunch.
Thank you.